Hello everyone, hope you are safe at your home. So from this semester I will be dealing with your discrete time signal processing subject. So this is the first lecture. So in this first lecture we will see introduction of the subject, what is the importance, syllabus and the marking scheme, what is the marking scheme of the subject, whether it is having practicals, so practical oral exam we will see in the detail itself. So we will see directly. So DTSP subject, it is the discrete time signal processing. We know that as signals we can divide it into continuous time CT and discrete time, that is discrete time, both kind of signal we are having. So we are using Laplace transform for continuous time and we are using discrete time, that is Z transform. So how to analyze these discrete time signals, how we are analyzing this discrete time signal? So continuous processing is there, so we are using the discrete time signal processing over there. So syllabus point of view, as for this we are having 4 lectures per hour, per week we have to deal with the 4 lectures, and UT1 20 marks, UT2 20 marks, so average of that will be of 20 marks, and end semester exam is there. So keep in mind there is no term work and external viva is there for this subject. So just what you have to do, only first sem, second sem, first UT, second UT, and only you have to give the 80 marks semester exam itself. No external examination is there, no term work is there for this one. Okay, so next. So the syllabus point of view, there are 6 modules as far as this DTSP is concerned. So very important module is that is nothing but the discrete Fourier transform and for FFT, that is DFT and FFT. This, as far as the exam point of view is concerned, this module, these 3 modules actually. The first module is there is the 15 to 20 marks compulsory they will ask you out of it, out of 120, because we know that there are 6 questions, 1 to 6 questions are there in the 80 marks semester. 1 to 6 questions are there, out of one first question is compulsory, and out of 5 questions you have to solve at least 3 questions are there. Okay, so 20 20 20 per question, so total 120 marks distribution is there. So out of this, the first module is that is for 15 to 20 mark, definitely they will ask you. Okay, the problem based on problem and property of this one. So what are this in the DFT? So in the DFT we have to see the definition, then properties of DFT, IDFT, then circular convolution of using DFTs. You know that circular convolution you have seen by using overlap and overlap save methods you have seen in the signal systems. So in this one you have to see by using DFTs how you have to calculate the DFTs of that one. Okay, the circular convolution using DFT and IDFT itself. Okay, then what you have to do, you have to go for the overlap save and overlap add methods for computation of DFT. DFT you can calculate by using either you can calculate by using DFT and FFT also, but one method is there, that is 2 methods are there, that are nothing but overlap save and overlap add, that we have to see again. Then the second bit of that one is nothing but the fast Fourier transform, that is FFT. In this one we have to see the radix 2.2 radix 2 decimation in DIT, that is nothing but we can say that it is nothing but the decimation in time. DIT we have to see, again we have to see decimation in frequency, both are the different terms are there, we have to see. Okay, so in these two means DFT and FFT, what we are doing, we are just calculating the time domain to frequency domain, but it is in the discrete format. Like this one, suppose we are having the signal like this one, U1 2 3 and 4. Okay, so if you want to calculate the DFT of that one, so how many points are there? 1 2 3 4, the 4-point DFT you have to calculate itself. Okay, so likewise DFT you will get the frequency components of this one, I mean, that is nothing but the complex version. Suppose 1 plus 2j, that is the first component you are getting. Likewise you are getting the 4 components, this is the complex part. From this you can calculate the its magnitude, frequency itself, magnitude and phase plot itself. So in the both DFT and FFT you will getting the same output. Okay, means by using a sequence of 1 2 3 4, I can say that, for example, if you want to calculate the DFT of this one, so we are getting the same answer as we are calculating the FFT also, but FFT is nothing to fast Fourier transform. Okay, so we'll see in detail while discussing the actual syllabus. So this is comes to the first module, DFT and FFT. The second module is nothing but the IR filters. So we know that we are having the category of filters like low pass filter, high pass filter, band pass and band stop filter, and all pass filter. Okay, so how to design that filters, we have to go for that one in the IR. Okay, IR filter will likewise whatever filters are there, cheapest filter, the names are new to you, but we will see in details how then mapping of S to Z plane. Okay, this is very important term. So as far as digital IR filters are there, because we know that in the S domain means the Laplace domain, we can say that Laplace domain, suppose this is nothing but my Laplace domain, and if I want to convert into the Z domain, okay, Z domain, so how to map that one? Some points are there in the S domain, so how to map to the Z domain? Because S transform, yes is nothing, Laplace transform, we are going for CT, continuous transform, continuous time, and Z transform we are going for the discrete time. So how to map this component with this one? So we have to see, okay, this is very important things are there. For that IIT means IIT method is there, that is impulse invariant transform itself. Then BLT is there, bilinear transform, you have to go for this one. Okay, so another, the next module is there, that is nothing but the FIR filters, that is the finite impulse response. The very this FIR is based on the completely on IR filters. So if you are knowing the IR filter, then you can find out the FIR filter. These two modules are very important. They definitely you will find the, if you, these three modules are, if you are very comfortable with this three modules, so you definitely will find near about 40 to 50 marks out of this, out of 80 marks, 120 marks, 40 to 50 marks will be based on this one, these three modules only. These are very important modules are there, and basically based on the problems. Okay, if you know how to calculate this one, you can easily find out the DFT and FFT of this one, IR filters. But these are not small problems based on this one. These problems are likewise we said, goal solving, it will require 2 to 3 pages for single problem itself. Okay, but small concepts are there. If you know that one, then you can easily find out each one. So carefully watch the videos again and again, and you will get the concept itself. So definitely that is my duty, that I will give you every concept. Okay, so next in the thing but the fourth module, finite word length effect in the digital filters. Okay, so we know that if you are normally our signals are every signals are there, that are the continuous signals. Okay, my voice is there, speech is there, then we can say that images are there, then some kind of sound is there, video, images, all these are the continuous signals. So if the computer want to, if you want to store it on the computer, so definitely you want to go for the digital. Okay, so in that one you will find one step is there, that is called as quantization. Okay, quantization is there. So what is the quantization? Then exactly the points related to that we will see in the this module, finite word length effect in the digital filter. Here you will find some kind of theoretical portion. Okay, so again the next module, that is nothing but the DSP processor. So DSP processors are nothing but what? So if you want to go for the projects like speech recognition itself, so how that input signal is there, my speech is there, and how to process on that by using different kind of operation like DFT, FFT and all that one. So for this one, the processor, DSP processor there, in this one you will find one process, that is nothing but TMS 320CX. Okay, so likewise the processor we have to study in this one. So this processor, if we will go for the practicals in this one, so we will use that TMS processor. So in this one you can find out lot of applications. Likewise the last module is nothing but the application of DSP, that is nothing but you can go for the ECG analysis. Okay, application of DSP for dual tone frequency signal detection. So you know that it is nothing but the DTMF, dual tone frequency. Okay, so so what is this? Normally we know that the our mobile phone is having keypad. Now it's in touch screen, but you will have like this one. So if you are pressing this one, so that is nothing but the one. It is 2, 3, 4, 5, 6, 7, 8, then I think 0 star hash, like this one. Okay, star hash, like this one we are having different one. So what they are doing here, they are giving some frequency. 100, 120, 130. Like this one, suppose this is a 400, 450. Okay, like this one frequencies are given to. Suppose I'm pressing this one, so 110 into this one, the frequency will add. That means that will recognize that one is pressed. Like this one, this process will done. Okay, so the last operation is nothing but the DSP process for radar signal processing. The whatever the signals captured by radar, that processing is there. So this is I can say that these are nothing but the theoretical modules, and the whatever the previous 1 to 3 modules are there are, they are totally based on problematic modules. Okay, so this is all about the syllabus discussion. So you can use these reference books like Digital Signal Processing, Practical Approach, Pearson Educations by Emmanuel Berry. The two